Let's take a look at a challenging problem that involves polynomial equations. So the dimensions of a give box are consecutive positive integers such that the height is the least integer and the length is the greatest integer. If the height is increased by 1 centimeter, the width is increased by 2 centimeters and the length is increased by 3 centimeters, then a larger box is constructed such that the volume is increased by 456 centimeters cubed. Determine the dimensions of each box. Okay, so whenever given a word problem, first start off by underlining or highlighting the key information. So we have consecutive positive integers. The height is the least integer. The length is the greatest integer. Okay? Now, if the height is increased by 1 centimeter, the width is increased by 2 centimeters, and the length is increased by 3 centimeters, then a larger box is constructed that will have a volume that's 456 centimeters larger than the original box. Okay? So let's first look at the original box. So we're going to let x represent the height of the original box. Then x plus 1 will be the width of the box, okay? Because we know we have consecutive integers. So if the height is the least integer and the length is the greatest integer, then the width will have to be in between the height and the length. Okay, so the width will be x plus 1 and the length will be represented by x plus 2. Okay, so 3 consecutive integers. Now, looking at the larger box, for the larger box, the height will be x plus 1 because it says that if the height is increased by 1 centimeter, then a larger box will be created. The width will be x plus 3 because we're taking x plus 1 and we're adding 2 to it. Okay, and the length will be represented by x plus 5 because we're taking the original, so we're taking the length of the original box, which is x plus 2, and we're increasing it by 3 centimeters. So that's why we get x plus 5. Okay, so the volume of the original box will be x times x plus 1 times x plus 2. Okay, so the length times the width times the height. Okay. And the volume of the larger box will be x plus 1 times x plus 3 times x plus 5. Okay, so once again, length times width times height. So the volume of the original box plus 456 is going to give us the volume of the larger box. Okay, so we get an expression where we have, so the volume of the original box plus 456 gives us the volume of the larger box. Okay, and so this is the polynomial equation that we're going to be working with in order to find the height, width, and length of the original box and of the larger box. So let's take a look at a visual representation of this situation. So we have the original box. Okay, so the height is represented by x, the length is represented by x plus 2, and the width is represented by x plus 1. So we add 456 to this box, and we're going to get a new box, a larger box, which is going to have a height of x plus 1, a length of x plus 5, and a width of x plus 3. Okay, so once again, volume of original box plus 456 will give us the volume of the larger box. Okay, so x times x plus 1 times x plus 2 plus 456 is equal to x plus 1 times x plus 3 times x plus 5. Okay, so now we're going to try to solve this equation for x. Okay, so first thing we're going to do is we're going to expand this part here. So we're going to multiply the x and the x plus 1 to get x squared plus x. Okay, and we're going to expand these two brackets. So we're going to get x squared plus 4x plus 3. Okay, so next we're going to expand further. Okay, so expanding these two, we're going to get x cubed plus 3x squared plus 2x plus 456. And on the right side, expanding these, we're going to get x cubed plus 5x squared plus 4x squared plus 20x plus 3x plus 15. So now we're going to collect like terms on both sides. Okay, so we're going to collect these two terms to get 23x. And now we're going to move everything to the left-hand side. Okay, so all the terms here are going to get moved to the left-hand side. And after we simplify that, we're going to be left with this quadratic equation. Okay, we're going to divide both sides by -1, or multiply both sides by -1, so that our leading coefficient becomes positive. So it's generally easier to factor if the leading coefficient is positive. But in this case, it's actually fairly difficult to factor this. So instead, we're going to use the quadratic formula. Okay, and so plugging our coefficients into the quadratic formula, we're going to get two values. X is equal to 7 and x is equal to -10.5. So we know that a length cannot be a negative value. Okay, so we're going to disregard this value. And so the only value that we're going to use here, which makes sense, is x is equal to 7. Okay, and so now going back to our original box, so x represented the height, x plus 1 was the width, and x plus 2 was the length. And for the larger box, the height was x plus 1, the width was x plus 3, and the length was x plus 5. And so the volume of the original was this expression, and the volume of the larger box was this expression. Okay, so the dimensions of the original box, if we substitute in 7 now, okay, so the height is going to be 7, the width is going to be 8, and the length is going to be 9. Okay, and for the larger box, if we substitute in 7, we're going to have, for the height, we're going to have 8, so 7 plus 1, 8. For the width, we're going to have 10, so 7 plus 3 is going to give us 10. And for the length, we're going to get 12, so 7 plus 5 gives us 12. So we have the original box, so a height of 7, length of 9, width of 8, plus 456, okay, gives us the larger box, okay, with a height of 8 a length of 12, and a width of 10. So just confirming that we calculated everything correctly. So 7 times 9 times 8 plus 456 is equal to 8 times 12 times 10. So we have 504 plus 456 is equal to 960. Okay, so this is just a way to check that we calculated everything correctly. Okay, so thank you for watching, and make sure you check out some of my other videos.